1.5, apply the remainder theorem and the factor theorem. Example 1, we need to divide this polynomial by this quadratic. So we're dividing the first by the second. First, I need to make sure that all of the degrees are there. We have x to the fourth, x to the third. I do not have x squared. We need to put 0x squared. And then we have our x. And we have our constant. So if the constant is not there, you need to add a 0. If any of the x terms, when you're going in descending order, are missing, you need to put a 0 there for that term. Okay, all of that is being divided by x squared minus 3x plus 5. We are looking for x squared to go into the first term here. What I need to have here, I need to have exactly a positive 3x to the 4th. So what times x squared equals 3x to the 4th? We always want the first term to cancel. What times x squared equals 3x to the 4th? That would be 3x squared. 3x squared times x squared equals 3x to the 4th. That is how you divide. You're always looking at the first term, and you want the first term to be exactly what is there. That way, when we subtract, it becomes a 3x to the 4th minus a 3x to the 4th, and they cancel. We're not done, however, multiplying. That is 3x squared times x squared is 3x to the 4th. 3x squared times negative 3x is negative 9x cubed. So I'm going to put it in the cube column, 9x cubed. And then 3x squared times 5 is 15x squared in the x squared column, positive 15x squared. Now we are ready to subtract. That means I need to put a parenthesis around all of my terms so that all of them are being subtracted. We know that a negative sign outside of the parenthesis is going to change all of the signs on the inside. I like to put my sign on top of the other sign. That way I know I've changed it. Sometimes you'll be in the middle of doing a problem, you look away, you get distracted, and when you look back, you might think you changed a sign, but maybe you didn't. So I just have the sign on top. That way I can clearly see that I've changed the sign. 3x to the 4th minus 3x to the 4th, those cancel, as they should. Negative 5x cubed, 9x cubed is going to be 4x cubed. And then 0 minus 15 is negative 15x squared. And I'm going to bring down these next terms, positive 4x and negative 6. And then I start all over again. Above the second term, what times x squared equals 4x cubed? That would be positive 4x. 4x times x squared is 4x cubed. Exactly what I needed, so they will cancel when I'm subtracting. 4x times negative 3x is negative 12x squared. 4x times 5 is 20x. Now we subtract. Change our signs. 4x cubed minus 4x cubed, negative 15, positive 12, negative 3x squared, and then 4 minus 20 is negative 16x, and I bring down my last term. Are we done, or do I continue? Can x squared go into negative 3x squared? Yes, it can. We know that negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x is a positive 9x. Negative 3 times 5 is negative 15. And again, we're going to subtract off, change our signs. Negative 3x and positive 3x cancel. Negative 16x and negative 9x is negative 25x. And then negative 16 and positive 15 is going to be 9. Can we keep going? Can x squared go into x? No, it cannot go into a degree that is smaller than itself. How we write our final answer then is, here's our answer. We have 3x squared plus 4x minus 3, and then here's our remainder. This is how we write our remainder. Negative 25x plus 9 over the divisor. X squared minus 3x plus 5. Final answer. Example 2. Divide f of x by this linear factor, x minus 2. We have x cubed, we have an x squared, we have an x, and we have a constant. I don't need to fill in any zeros. Divided by this linear factor, x minus 2. What times x is x cubed? X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Subtract. Change your signs. These cancel as they should. 5x squared minus 2x squared is 3x squared. And I'm going to bring down my other terms, my negative 7x, my positive 2. What times x is 3x squared? That would be 3x times x is 3x squared. 3x times negative 2 is negative 6x. Subtract. Change your signs. 3x squared minus 3x squared cancels. Negative 7x and positive 1x is negative x. And bring down your last term. What times x equals negative x? That would be negative 1 times x is a negative x. Negative 1 times negative 2 is a positive 2. And when I subtract and change my signs, negative x and positive x cancel, as do 2 and negative 2. Remainder 0. That's going to be key moving forward. When I get a 0 remainder, that's what we want. That means that the linear factor x minus 2 is one of the factors of this x cubed. It's a degree 3. We expect 3 answers, and here's one of the factors. Remainder theorem. If a polynomial f of x is divided by a binomial x minus a, the remainder is r equals f of k. Use the remainder theorem to find f of 3 when f of x equals x cubed plus 2x squared plus 4. We are going to substitute in 3. It says f of 3. When I substitute 3 into the function, what do we get? Three cubed is 27. 3 squared is 9 times 2 is 18 plus 4. F of 3 equals 49. When we substituted in 3 for x, we found that y was 49. That means when I got a remainder of 49, that 3 is not one of the solutions. Example 4. Divide the first by the second. Use synthetic division. This is how we do synthetic division. Synthetic division is a shorter version of long division. Here's our long division. You just need to have good algebra skills to show that you can do it. But what we use is synthetic division. All right, we have 2x cubed, x squared, we have an x term, and we have a constant. X cubed, x squared, x to the 1, and x to the 0, or the constant. So all of my terms are here in descending order. You peel off the coefficients. That would be 2, 1 for the x squared, negative 8, and 5. Then we take, and we need to solve for the linear factor, x plus 3. We need to solve for x. We see that x equals -3. We would like to use -3 in the synthetic division. And we're all set to go. The first thing you do is bring down the first term, and then it's multiply, add, and subtract. Multiply, add, and subtract. 2 times -3 is -6, and then you combine these together. 1 minus 6 is -5. -5 times -3 is 15, and then 15 minus 8 is 7. 7 times -3 is -21, and then our remainder here is going to be -16. That means that x plus 3 is not a factor of the polynomial. We want to get a 0 for our remainder. I started out with a degree 3. And when I divided by a linear factor, x to the 1, this is a linear factor. Synthetic division can only use linear factors. You can't do any kind of dividing unless it's a linear factor. On the previous example, we could not use synthetic division because this is not a linear factor. So if it's not a linear factor, you have to do long division. When I have an x cubed and I divide it by an x, that brings it down a degree. So this is now x squared. This is my x. This is my constant. And this is my remainder. This is how you write your final answer. My final answer then would be 2x squared minus 5x plus 7. And then here's my remainder. So plus -16 over x plus 3. And here is the factor theorem. When we substitute in a and we get 0 for a remainder, that means that x minus a will be a factor. So x minus a will be a factor if and only if f of a equals 0. The remainder equals 0. Factor completely, given that x plus 2 is a factor. So we already know that x plus 2 is a factor. If x plus 2 is a factor, we expect to get a 0 at the end. No remainders, it divides in evenly. When you get a remainder, it's not dividing in evenly. We have 3x cubed negative 4x squared minus 28x minus 16, x cubed, x squared, x and the constant, so we have all of our terms, 3, negative 4, negative 28, negative 16. X plus 2 is a factor, and we need to find the x. So when x plus 2 equals 0, we get x equals negative 2. That's what we want to use to divide by. Bring down your first term, and then multiply. 3 times negative 2 is negative 6. Add up these two right here to get negative 10. Negative 10 times negative 20 is 20. Negative 28 and 20 is negative 8. And then negative 8 times negative 2 is a positive 16. And when I combine these together, I get a 0, which is what I expected to get at the end of synthetic division. I have an x cubed that I started with. I divided by a linear factor. That gives me x squared. We have one of the factors was x plus 2. And now I'm going to rewrite this. This is x squared, x, and the constant. So we have 3x squared minus 10x minus 8. It says to factor completely. Here's x squared. Is this going to factor? Three is prime, so we only have 3x times x. That equals 3x squared. 8 has factors of 1 and 8, 2 and 4. Let's try 2 and 4. Here we have 3x times 4 is 12x. Our inner term is 2x. Our outer term is 12x. Can I get 12x and 2x to add to negative 10? That would have to be negative 12 and positive 2. Negative 12 and positive 2 also. Let's see here. So positive 2x and then negative 4 for negative 12x. Our final answer is x plus 2 times 3x plus 2 times x minus 4. Fully factored down into linear factors. Final answer. Example 6, factor to find the roots of f of x if f of 2 equals 0. This time we need to make sure that we're factoring and then finding the roots. They're telling us that f of 2 equals 0. That means that 2 is the number that goes in the box. And then we peel off the coefficients, x cubed, x squared, x, and the constant. So we are going to peel off those coefficients. We have all the terms in descending order. Don't forget your 1's in front of your x's or your minus signs, your negative signs. We have 1, 6, negative 1, and negative 30. Bring down the first term. 1 times 2 is 2. 6 plus 2 is 8. 8 times 2 is positive 16. 16 minus 1 is 15. And 15 times 2 is 30. Negative 30 and 30 is 0. F of 2 equals 0. Find all the roots. So we already know that 2 is a root. The factor here is x minus 2. Remember, if we solved for this, it would be 2. We started with a degree 3, and now we're down to a degree 2. So I'm going to rewrite my quadratic, x squared plus 8x plus 15. We have a degree 2 that we need to factor. X times x is x squared. 3 times 5 is 15, and positive 3 and positive 5 equal positive 8. Now we need to find the roots. We set it equal to 0, and we solve all of our factors. We get x equals 2, x equals negative 3, and x equals negative 5. Here are the roots, and we knew the first root. We needed to find the other two. Do I expect you to go from your factors to these equations to solving? No. I think that you can go from here right to the answer. But these are your notes, so you should fully understand what it is you're doing. Example 7. 1 0 of this polynomial is x equals 3. So we already know one of the zeros. What is another 0 of f? Okay, so we know that 3 is one of the zeros. We have x cubed, x squared, x, and the constant, so all of my terms are there. Peel off the coefficients, we get 1, negative 2, negative 23, and 60. Bring down your first term. 1 times 3 is 3. Negative 2 and 3 is 1. 1 times 3 is 3. Negative 23 and positive 3 is negative 20. Negative 20 times 3 is negative 60, and 60 minus 60 is 0. We expect to get a 0 at the end when we have one of the zeros here. We started with a degree 3, and now we've divided down to a degree 2. We have x minus 3, and then x squared plus x, or 1x, minus 20. Degree 2 means I'm going to factor if it's possible. If not, I would have to use the quadratic formula. I'm looking for one of the zeros. We're looking for a zero that's crossing the x-axis. Those are the zeros. It's a degree 3. You expect to have 3. Okay, does this quadratic factor? X times x is x squared. And then I'm looking for a 1, so those numbers would have to be close to each other, like 4 and 5. 4 times 5 is 20. I need a positive 1x, so that would be positive 5 and negative 4 would add to 1x, and negative 4 times 5 would multiply to negative 20. And now I just solved. Set it equal to 0 and solve. We get x equals 3, 4, and negative 5. We just found where the polynomial